Now that we've looked at different types of transformations, such as vertical and horizontal shifts, reflections, compressions, and stretches, I want to look at some examples of how we can sketch graphs using a series of transformations where more than one transformation is contained in the same function. The first thing I'd like to note is that vertical and horizontal transformations are independent of each other. So when you're talking about how are the x values changing and how are the y value changing, it does not matter in which order you apply those transformations. When we work with vertical transformations, transformations that affect the y values or output values, we follow order of operations. We work from the inside out. However, horizontal transformations are combined by working backwards from the outside in, and I hope to justify that with one example in this video. So let's consider three different examples. First, I want to sketch the graph of y equals the square root of x plus 3 minus 1. This is based on the toolkit function, y equals the absolute value of x. And let's think about the transformations that are occurring. This minus 1 at the end is a vertical shift. We're going to take all the y values and subtract 1, so we're moving 1 unit down. This plus 3 inside the function is a horizontal shift, and remember that's going to move us in the negative direction. So we're going to take all the x values and subtract 3, moving the function 3 units left. So without making a table of values, I think that I can visualize that on my new graph. I have some points noted on the original function, 0, 0, 1, 1, 4, 2. Let's think about taking each of those points and just moving them 3 units to the left and 1 unit down. So instead of 0, 0, I will now have negative 3, negative 1. Instead of 1, 1, I will now have negative 2, 0. And instead of 4, 2, I will now have 1, 1 right here. So here is what our transformed function looks like. It's the same shape as y equals the square root of x. It's just moved 3 units to the left and 1 unit down. And one thing we see there is it does not matter which order I think about the transformation. If I move first 3 units left and then 1 unit down, that is the same result as moving first 1 unit down and then 3 units left. So vertical and horizontal transformations are independent. In our second example, I want to look at a couple of vertical transformations. Here we're asked to sketch the graph of y equals negative x squared plus 3. So there are two things going on here, and they both affect output values or y values. We are reflecting the graph across the x-axis. So it's a vertical reflection. The graph is being flipped upside down. And we are moving the graph up 3 units. These transformations both apply to the y values, and it's a good idea to follow order of operations here when I think about the order in which I apply them. So let's say you are taking the function x squared, following order of operations. What are we doing to it? We're multiplying by negative 1, that's what the negative sign in front means, and we're adding 3. So in order of operations, multiplication comes first. So I'll do the reflection first. Let me visualize that on this original graph. If I do a reflection, I'll have a parabola that's going downwards from 0, 0. And then I'll take every unit, every point, and move it up 3 units. So instead of a vertex at 0, 0, I have a vertex at 3, 0. I think we'll end up with a point here, a point here, and so on. This is enough to provide a rough sketch of this graph. So there we followed order of operations. I did the reflection first, and then I moved up 3 units. Finally, let's look at an example that involves a couple of horizontal transformations. So I want to sketch the graph of y equals 1/2 of x plus 1 cubed. So all of this multiplication and addition is happening inside parentheses here, and that means that these are horizontal transformations affecting our x values. Let's think about what's going on here. This plus 1 means every point is moving 1 unit to the left, and this 1/2 is a horizontal stretch. I'm going to write here every x value gets multiplied times 2. But we do need to consider the order in which to apply these. And for horizontal transformations, we actually work from the outside in to the x value. So let me try to justify that with taking a couple examples from this graph of the toolkit function. So here I have some x and y values for the original function. And let's say that we're looking at the point 1, 1, and we're wanting to find which point, what x value on this new function would result in that same output of 1. So I could set up an equation here, right? I could say 1/2 of x plus 1 cubed equals 1. I'm wanting to know what x value in this new function gives an output of 1. Well, think about how you would solve this equation for x. You would work from the outside in. So I would take a cubed root of both sides, and I would have 1/2 times x plus 1 equals 1. I would multiply both sides times 2 to undo the 1/2. I would have x plus 1 equals 2, and I would subtract 1 from both sides, and I get x equals 1. So an input value of 1 in the new function also gives us an output of 1. Alright, but pay attention to the order in which we did that. The multiplication by 2 came first, and then the subtraction by 1. We worked from the outside in to isolate x. So as I set up a new table of values for this function, y equals 1/2 of x plus 1 cubed, I'm going to take every x value, I'm going to multiply it by 2, and then I'm going to subtract 1. So think of 0, 0. 0 multiplied by 2 is still 0. I'll subtract 1, and I get negative 1. Think of 1, 1. 1 multiplied by 2 is 2. I subtract 1, and I still get the point 1, 1. So that point did not change. What about negative 1, 1? Let's multiply by 2 and subtract 1, and I get negative 3, negative 1. And we continue this pattern for each point. So 2 multiplied by 2 is 4. Subtract 1, we get 3, 8. Negative 2 multiplied by 2 is negative 4. Subtract 1, we get negative 5, 8. So let's try to sketch this function that we've created now. So I have negative 1, 0. I have 1, 1. I have negative 3, negative 1. I have 3, 8 up here, and negative 5, 8. Negative 5, negative 8 down here. So here is my new cubic function with the transformations applied.